All right, let's dive right into this explainer and settle a decades-old debate in the hi-fi world. Today, we aren't just talking theory, we're actually going to learn exactly how to build our own ultimate PC audio setup. Whether you're a hardcore audiophile or, just someone trying to get the absolute best sound at your desk, the physics of how music actually reaches your ears is just super fascinating. For decades, literally decades, this one single question has sparked endless, sometimes really heated debates among music lovers: active or passive speakers. If you jump into any high-fidelity forum, you're going to hit this massive divide almost immediately. And it's not just a minor technical detail either. It dictates the entire architecture of how sound is reproduced, and it fundamentally changes everything about your listening experience.
So, here's our roadmap for today. 1. The quest for perfect sound. 2. The passive speaker problem. 3. The active speaker solution. 4. Inside an active system. 5. Building a DIY 2.1 system. And 6. The future of audio. Let's get right to it.
Section 1. The quest for perfect sound. Let's look at why the loudspeaker is the absolute core of your music setup.
We really have to start by acknowledging that while every single component in a hi-fi system matters, from the acoustics of your room right down to the recording itself, the loudspeaker is absolutely the decisive element. And the secret hiding inside almost every multi-driver speaker? It's the frequency separating filter. We call it the crossover network. Think of it kind of like a traffic cop, directing the high notes to the tweeter and the low thumbs to the woofer. How a speaker splits this traffic, whether actively or passively, literally changes the physics of your music before it ever reaches your ears.
Moving on to Section 2, the passive speaker problem. We've got to talk about massive components and electrical resistance.
Now, what's really fascinating here is the order of operations. Passive systems still completely dominate the consumer market today. But look at how they work. The audio signal leaves your receiver, gets amplified to a massive degree, and only then hits the passive crossover inside the speaker to be split up. So a fully amplified, high-voltage signal is forced to slam right into heavy electrical resistance. Active systems, they completely flip the script. They split the weak, unamplified signal first and then send it to dedicated amplifiers.
To understand why that's such a big deal, just look at the hardware itself. Because the audio signal hitting a passive crossover has already been so powerfully amplified, the physical components, the spools, the resistors, the condensers, have to be incredibly massive just to survive the sheer amperage. Forcing a high-current music signal to fight its way through these heavy components acts like a physical roadblock. It causes distortions, phase shifts, and a severe degradation of the original audio. But okay, this is the most shocking takeaway for me. What this roadblock actually does to the damping factor, this is your amplifier's ability to precisely control the speaker membrane. Imagine you're driving a car. When you hit the brakes, it should stop instantly, right? Well, those massive passive crossover components effectively grease the brake pads. Even the absolute most expensive passive networks on the market diminish an amplifier's damping factor down to a pathetic 5% of its original value. You are literally throwing away 95% of your amp's physical control. Crazy, right?
So, how do we fix this? That brings us to Section 3, the active speaker solution and the pursuit of lossless precision.
The difference in the signal path here is just night and day. We know the passive setup forces a massive signal through a restrictive filter. But in an active setup, that original, very weak audio signal comes in and immediately hits an electronic crossover. It gets split into highs, mids, and lows with almost zero resistance. Then, each individual frequency band gets sent to its very own dedicated amplifier, which connects directly to the speaker driver. No massive spools, no roadblocks, just perfect, uninterrupted physical control.
Section 4. Inside an active system. Let's take a look under the hood at the sleek electronics making this possible. When you compare this to that huge passive block of heavy spools from earlier, the elegance of active technology is super obvious. Because an active crossover gets the signal directly from the source, like your PC sound card or your preamplifier. Before any amplification even happens, the signal is weak and delicate. It doesn't need giant, power-hungry components. Instead, it uses a sleek, highly efficient circuit board that splits the frequencies with practically zero signal loss, preserving your music perfectly. Now, you might be thinking, wait, if we pack 3 different amplifiers inside a wooden speaker cabinet, isn't it going to turn into a desktop oven? Historically, yeah, for sure. Older amp designs ran incredibly hot. But modern engineering has completely solved this using pulse width modulation, or PWM amplifiers. These boast an unbelievable efficiency of more than 90%, which means they produce only 1/5 of the heat of older amps. Overheating is totally a thing of the past.
All right, now that we've got the physics down, let's move to Section 5, Building a DIY 2.1 System. Time to put this theory into practice.
Our source material actually provides an awesome modular guide for building your own active 2.1 system for a computer workstation. We are moving way past the days of just settling for basic motherboard audio. To transform your desk into a legit hi-fi listening room, it's just a simple 4-step process. First, define your expectations. Second, select your drivers. Third, construct that sleek active crossover. And finally, assemble the dedicated amplifier modules.
For this specific PC build, our source outlines a seriously capable setup. For the desktop satellites, we pair a high-frequency dome tweeter with a really solid mid-bass driver. And to ensure your games and movies actually feel like a cinema experience, we add a dedicated subwoofer to vigorously support the bottom octaves. And here is the golden rule of this whole build. Because it's an active system, every single one of these drivers gets its very own perfectly matched amplifier module. We totally bypass the massive signal loss of a passive system.
Which brings us to our final takeaway, Section 6, the future of audio and making the choice for your own setup.
You know, if you look at the professional studio world, the active versus passive debate was settled a long time ago. They don't even argue about it anymore. Active is just the standard. And this fantastic quote from the respected magazine Image Hi-Fi really hits the nail on the head. They basically advise us to stop obsessing over exotic, expensive speaker cables and standalone amps. They stated flatly, no driver, as perfect as it may be, can give back what the passive crossover network takes away. Once that signal hits the passive roadblock, the detail is literally gone forever.
So, as we wrap up this explainer, let's think about where this leaves you. We've seen how active systems offer almost lossless signal processing, absolute physical control of the speaker membrane, and just incredible DIY possibilities for your own PC workstation. Knowing the raw physics, the only logical question left to ask yourself before your next audio upgrade isn't really whether to choose active or passive. It's simply, why are we still settling for passive? Thank you so much for joining me today, and I really hope this changes how you look at the speakers sitting on your desk right now.